Hello again. We are continuing our discussion of solving quadratic equations, and we're going to talk about a different strategy today, which is using square roots to solve those quadratic equations. The goal here is to isolate whatever is being squared on one side of the equal sign and put everything else, no matter how messy, on the other side of the equal sign. So let's go through some examples. If I start with x squared minus 11 equals 38, then the quantity that's being squared is just the x. That's what's being squared, so that needs to be by itself on one side of the equal sign, and everything else needs to be on the other side. So to fix that problem, I'm going to add 11 to both sides, and that gives me x squared equals 49. Now I can square root both sides, and the square root of x squared is just x, and the square root of 49 is either positive 7 or negative 7. So those are the two solutions to that equation. If I needed to solve something a little more complicated, like 2x squared plus 18 equals 68, now I have two things to get rid of, and that's the 2 in front of the x squared and the 18 that's being added. So I'll get rid of the 18 first by subtracting 18 from both sides, and I get 2x squared equals 50. Now to get rid of the 2, I'm going to divide both sides by 2, and I get x squared equals 25. So if I square root both sides now that the x squared is isolated, the square root of x squared is just x, and the square root of 25 is either positive 5 or negative 5. And you have to remember that when you're square rooting, there's always going to be a positive and negative possibility for what the square root is. So please consider both of those. All right, and now if I'm solving 3x squared plus 1 equals 16, it's the same process. I need to get rid of the 3 and the 1 that are on the left-hand side so that I can isolate x squared. So if I subtract 1 from both sides, I get 3x squared equals 15. And then if I divide both sides by 3, I get that x squared equals 5. So now I can square root both sides. The square root of x squared is just x, and then the square root of 5 is either root 5 or negative root 5. So those are my two solutions. All right, now sometimes there are parentheses, and I need to consider those cases. So let's go through a few of those. The thing that's being squared right now is not just x, it's x plus 5. So that has to be isolated. So if I divide both sides by 2, I will isolate the x plus 5 squared, and I will get x plus 5 squared equals 81. Now I'm ready to square root both sides. And so the square root of x plus 5 squared would just be x plus 5, and the square root of 81 would be positive 9 or negative 9. So remember, I need to consider both, because here's where my solutions become very different numbers. So I need to solve each of these new linear equations separately, and so I subtract 5 from each side. For the first one, I will get x equals 4 if I do that, and for the second one, I will get x equals negative 14. So very different solutions this time when I've got something in parentheses. All right. Similarly, if I have 3 times x minus 1 squared equals 63, then again I need to divide both sides by 3 because it's not something that's being squared. So I divide both sides by 3, and I get x minus 1 squared equals 21. So now the x minus 1, which is being squared, is by itself on the left-hand side, and I'm ready to square root both sides. If I do that, I get x minus 1 equals the square root of 21, or x minus 1 equals the negative square root of 21. All right, and so now all that's left is to solve for x, and in both of those equations, that means I need to add 1 to both sides. If I do that to the first equation, I get x equals positive 1 plus root 21. And if I do that to the second equation, I get x equals positive 1 minus the square root of 21. Okay, so that's just an idea of how to solve quadratic equations using a different strategy. If you have any questions, please let me know, and I will see you tomorrow.